Morning students, today we will start the new chapter, that is physical quantities and measurement. What do you mean by the physical quantities? Physical quantities are the quantities which we can measure or which can be measured. For example, mass, length, time, etc. All these are known as physical quantities. Now how we are going to measure that? In measurement, we are actually comparing two things. One is known to you and one is unknown to you. So, measurement is the comparison of an unknown quantity with a known physical quantity of same kind. This is a keyword, you need to write it. Same kind, it should be of the same kind. For example, after the measurement, we are going to write the values, like if we have measured the length of a pen. This pen I have measured. So length is coming out to be 5 centimeter. In this we have written three things here. This is known as the physical quantity, whichever we are measuring here. This is its numerical value, how many times it is coming in that. And this third one is centimeter, is the unit. Now what is this unit? Unit is that standard quantity of that same kind which we are measuring. Now the systems of unit. Earlier we were having three systems of unit known as MKS system, FPS system and CGS system. All these got failed up. Why? Because we are able to measure only three physical quantities, as three units are given in all these three systems. And these physical quantities are length we can measure in these three systems, mass we can measure and time we can measure. Other than these three physical quantities, we are not able to measure in these three systems of unit because we don't have any unit in these three systems, so they got failed. Now with the discoveries we come to know that there is a fourth system, that is the SI system, which is globally applicable, in which we have in total 9 units, out of which 7 are known as fundamental units and 2 are known as supplementary units. Out of these 7 fundamental units, we will only focus on the 3 units, that is for mass, length and time. Up to this class, we will focus only these 3. So mass in SI system, mass is measured in kilograms and it is written as this way. Length is measured in meter, written as small m. Time is measured in second, written as small s. You cannot manipulate these signs, so be strict to these symbols only. Now, are we able to convert a physical quantity from one system of unit to another system of unit? Yes, we are able to convert, but we are restricted with the three quantities only, because in these three systems we have three physical quantities which we can convert. Other than this, we are not able to convert in these three systems. So, for these three physical quantities, we can convert from SI system to CGS system. Let us do this one, or from CGS system to SI system. Let us take an example. 5 meter, we have to convert it into centimeter. We are aware that 1 kg is equals to 1000 grams and 1 meter is equals to 100 centimeter. We have to learn these conversion values. With the help of them, we are going to convert. So we know that 1 meter is equals to 100 centimeter. So 5 meter can be written as, instead of meter, I can write 100 centimeter because I know 1 meter is equals to 100 centimeter. So instead of meter, I will write 100 centimeter and we will get converted into now centimeter. It is coming out 500 centimeter. The thing which you have to remember is that when you are going from bigger unit to smaller unit, we need to multiply that value. And if we are going from smaller unit to the bigger unit, we need to divide that value. Let us take an example here again. We will take the conversion value here. 1 meter, we know that is equal to 100 centimeter. So if we want to convert meter into centimeter, we need to multiply that value simply with 100. And if we are going from centimeter to meter, we need to divide that value with 100, or you can write multiply that value with 1 upon 100. Let us take an example again here. This you need to solve by your own. 50 kg to grams, you have to convert this. Now the next is density. You have already done in the previous class 7. So density, we know that mass per unit volume. If we are aware about the formula, then we can find its unit in SI system as well as in CGS system. So let us find it in SI system. Density can be written as mass per unit volume, and in SI system mass is measured in kg, and volume we know basically volume is what? Length into breadth into height, and all these three are distances, and distance in SI system is measured in meter. So we will write meter into meter into meter, and it will become equal to kg per meter cube. Similarly, we can derive the CGS unit. In CGS unit, mass is measured in grams. Volume is again length into breadth into height. So length is measured in, or you can say distance is measured in centimeter in CGS system, so it will be centimeter into centimeter into centimeter. We will have gram per centimeter cube. Now we can find the value. If you want to convert directly kg per meter cube to gram per centimeter cube, how we are going to get? For this we know that 1 kg is equals to 1000 gram, 1 meter is equals to 100 centimeter. Now 1 kg, instead of writing 1 kg, I can write 1000 grams, and instead of write meter cube, I can write centimeter cube with the value. So meter cube can be written as meter into meter into meter, and 1 meter is equals to 100 centimeter. In place of all these meter, I have written 100 centimeters. So calculate the value here. Now in the denominator we have 6 zeros, in the numerator we have 3 zeros. We will cancel out 3 zeros there. So we are left with 10 to the power minus 3 gram per centimeter cube. So if you want to convert directly kg per meter cube to gram per centimeter cube, you need to multiply that value with simply with 10 to the power minus 3. Relative density. In relative density is basically the ratio of density of substance to the density of water at 4 degrees centigrade. This is the keyword here you need to write. Otherwise you will lose your marks here. So why we have taken water at 4 degrees Celsius only? Because the density of water is maximum at 4 degrees Celsius because of its anomalous behavior of. So SI, now we are going to derive, we know the formula, so we can derive the SI unit. How we are going to derive it? Here is the formula. As you can see, in the numerator and denominator, we both have the densities, and we know the density SI unit kg per meter cube. So they are going to be cancelled out. That's the reason it has no units. Now important point which you have to learn here is that density of water is equal to 1 gram per centimeter cube or 1000 kg per meter cube. You have to learn the values along with the units. Now next is the measurement of the definite solid shape. We can measure the solids, liquids. How we are going to measure? For the definite shape, we have instruments like ruler, inchi tape, etc. With the help of these, we can measure definite shapes. And for liquid, we have instruments like measuring cylinder, measuring beaker, density bottle, etc. Irregular shapes or irregular solids, we have other procedure to measure the irregular solid. This we have already done in the class 7 activity. So we are not going to in detail with all these instruments. Now end up with the numericals. These are important. I have divided every numerical in 5 steps. First is write what is given in the question and check their units. If all the given quantities are in the same system, then it is right. Keep them as it is. If they are not in the same system, then you have to convert them into the same system. Second step, you need to write what you need to find out. Third step, write the formula appropriate according to the given quantities and according to the quantity which you need to find out. Fourth is put the values. Fifth is calculate and write answer with the unit. Don't forget to write unit with the answer, because if you will not write unit, you will lose your marks here. So let us proceed with an example. 20 meter cube of iron weighs 20 gram. Find the density of iron in kg per meter cube. Now the question is asking specially in the SI unit. Answer in the SI unit. So let us start with the first step. You have to write down what is given in the question. Volume is given 20 meter cube. Mass is given 20 grams. Now see, check the units. This is SI unit, this is CGS unit. So you need to convert, as the question is asking answer in the SI system, so you need to convert CGS unit into the SI unit. So I have divided 20 divided by 1000 kg. Now second step, write what you need to find out. You need to find out density. In which unit? Kg per meter cube. Third step, write the formula. Density, we know that, mass per unit volume. Fourth step, now put the values here. Mass is given, that is 20 divided by 1000. Divide by volume. So volume is given in the question, that is 20 meter cube. So simply put the values. Now calculate these values, and fifth step, write the answer along with the unit. Don't forget to write unit along with the answer. I'm telling again and again, because if you will forget it, you will lose your marks here. So in this way we will solve the numerical. One more example here. Question is, density of copper is 50 kg per meter cube. What is the mass of 10 centimeter cube of copper? Now again follow up these 5 steps. First, write what is given in the question. Density is given. You can check with the unit that this is density given. If you are confused what is given, then check their units. With the help of the units, you come to know that which physical quantity is given and which physical quantity you need to find out. So density is given 50 kg per meter cube, which is an SI unit. Volume is given 10 centimeter cube, which is a CGS unit. So both are not in the same unit, so we need to convert either of the one. So it is not specifically asked in the question whether the answer should be in SI or CGS. So it's all up to you. You want to find answer in CGS, then convert this unit. If you want to find out answer in SI, then convert this one. So I'm finding the answer in the SI unit. So I have to convert this centimeter cube to meter cube. Now simply write centimeter cube can be written as centimeter into centimeter into centimeter. So 1 centimeter is equals to 1 upon 100 meter. So put the value and you will get 10 to the power minus 5 meter cube. Now second step, write what you need to find out. Mass we have to find out. Now fourth step, write the formula. We know that density is equals to mass per unit volume. Now check density is given, volume is given, mass we have to calculate. So we will use the density formula. So mass can be written as simply cross multiplication is there. Mass is equals to density into volume. Fourth step, put the values. Mass is equals to density given 50 kg per meter cube and volume we have calculated 10 to the power minus 5 meter cube. Now fifth step, calculate and write the answer. We have calculated it. We will get the answer as 5 into 10 to the power minus 4 along with the unit, that is kg. So in this way we will solve each and every numerical. The topics which I have covered in this video is the syllabus from this chapter only. Thank you so much.